Now we will discuss about the connection of resistors. There are two types of connection. One is series and another one is parallel. What is the difference between first suppose take three resistors. Here are suppose here is three resistor of resistance R1. Here is resistor of resistance R2, and here is resistor of resistance R3. Then how will you connect so that it is said to be series? Series connection is end to end connection is called as series connection. What is end to end? That is the end. This is the end. And this connecting this type of this. Suppose I will connect like this. This is called as the series connection. Here is the suppose positive end. Here is the negative end. That end to end connection is called the series connection. Similarly, parallel connection is connecting all the ends with both positive, combiningly both with positive side and with negative side. How this is? Suppose I will connect like this. Suppose here is the three resistors. If I will connect like this, this is suppose positive end, this is suppose negative end. This connection is called as parallel connection. Then how will we measure the both the resistance in both the connection? First, suppose we will consider about the series connection. Suppose first, now here I have drawn the circuit diagram. Suppose here is the resistors R1, R2 and R3 connected in series. Suppose I amount of current flow through this wire. Ammeter measure this I amount of current, and later we will get the same I amount of current as it is connected in series. In all the cases we will get I. But if you measure the voltage between these two ends, you will get one. That means if you measure the voltage between these 2 points, you will get V1 amount of voltage. As this is different types of material or different type of resistor, so between these two ends you will get different types of voltage. Similarly, in this case you will get V3. So that means in case of series connection, the same amount of current flow through all the resistors, so current remains same in series connection. But in case of voltage it is different. You have to remember this much. So now that means here is suppose if you will get that means suppose if you will find total amount of V between these three, that means this V equal to V1 plus V2 plus V3. We know that from Ohm's law the formula for V by I equal to R implies V equal to IR. If I will get V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. Why I am not taking the I1, I2, I3? Because I is same. Here is V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. So putting in equation 1 all these, we will get V. In case of V, it is IR equal to V1 plus IR1 plus IR2 plus IR3 implies taking common I. Here is as we are connecting in series, we can take total resistance equal to RS. So I into RS equal to I taking common R1 plus R2 plus R3 implies cancelling I from both the side, we will get R series equal to R1 plus R2 plus R3. That means in case of series connection, total resistance is always greater than the sum of the resistance. Generally, we do not connect the home appliances with the series connection because the total resistance will increase, so as the heating effect will increase, because resistance is the opposing force and it will create the heating effect. Now we will discuss about the parallel connection. Let me draw the circuit diagram first. Now from this circuit diagram we can clearly observe that suppose here is I amount of current flow from positive end to negative end, then this I amount of current will divided, because here are three connections, so this current will divide as I1, I2, I3, taking the reading through the ammeter, 3 ammeters. But the voltage will remain same in all the 3 resistors, because here we will measure the voltage. Suppose we will measure the voltage of the resistance R1 from this by connecting the voltmeter with these 2 ends, so it will read V volt. Suppose I will consider about the another resistance, as we are connecting with the same end. Here is the two end of the resistance R2, so it will read the same V. Similarly, for this resistance R3, we are connecting the voltmeter with the ends, 2 ends, so it always will, in the parallel connection, the voltage always remains same, but the current divided into the different sections. So we can, in this case, we can say that total current equal to I1 plus I2 plus I3. Similarly, from the formula we know that V by I equal to R implies I equal to V by R. Putting these value, for I1 it will become V by R1, because V is constant, so we have to take the V constant, but resistance is different, so R1. Similarly, I2 equal to V by R2, I3 equal to V by R3. Putting all these in equation 1, we will get V by R equal to V by R1 plus V by R2 plus V by R3. Implies taking common V, 1 by R equal to V taking common 1 by R1 plus 1 by R2 plus 1 by R3. Cancelling V from both the side implies 1 by R equal to 1 by R1, or you can write the RP, parallel connection. So RP equal to 1 by R1 plus 1 by R2 plus 1 by R. This is the formula for parallel connection in the circuit to find the total resistance. See this figure. Generally home appliances are connected in parallel, because suppose this bulb requires some amount of current and heater required a different amount of current. So to give the different types of amount current, we generally connect the circuit in home appliances in parallel. And another thing is, suppose if we connect the circuit in series, suppose this is the electric bulb and this is the heater. Suppose the bulb will become fuse. Can the current pass through this circuit, or can the current fulfill the circuit? No, it cannot. How? Because here is the wire or filament is damaged or fused, so that the current which is flow through this, and it cannot pass through the bulb and cannot reach to the heater. So that if we connect in series, then all the circuit lines will be closed if one thing will become damaged. But in case of this, if the bulb will become fused, easily current can pass to the heater. So that generally in home appliances we generally connect in parallel and cannot connect in series to avoid this demerit.